Hello and welcome back to Jacobication. This is the first video, chapter 0, entitled Straight Lines. Why that's the title, you won't know too much yet. By the time you watch the next video, it will make sense. A few background definitions. Programming is writing stuff for the computer to do. A bit like a recipe or driving directions. It's step-by-step instructions for the computer to accomplish a certain end goal. A programming language is a certain, well-defined, human-understood system for telling the computer to do a thing. There are many different programming languages. Comments? Little notes to yourself or other future readers of your code. They should remind you of the bigger picture of why your code is doing what it's doing. For example, once you get the basics down, you'll know x plus y, assuming x and y are numbers, is adding x and y. Your comment should say why you're adding these numbers. Many languages follow this style. // this is a single line comment, or / asterisk, and then this is a multi-line comment, or the asterisk isn't strictly necessary on every line. Some languages follow different styles. What is a variable? A username storage location with an associated value. What's a storage location? Memory, which almost everyone knows what memory is, where your variable lives. Thinking inside the box. A variable is conceptually a box. The variable's name is like a labeled piece of masking tape on the outside of the box. The variable's value is stored in the box. The variable's type limits what can be done to it, what kind of values it can hold. The variable's address is where it is stored in memory. Here's 3 different variables from 3 different languages, variable declarations. X equals 5, that's from Python. Int x equals 5, that's from Java, and let x equals 5, that's from JavaScript. The value you want to put in the variable is always on the right. Why? You'll see that in a couple of slides. Declaration versus assignment. Declaration makes a variable exist, while assignment puts a value in the variable. Depending on the language, declaring a variable and assigning it a value can be 2 different steps. The let. There can't be information other than the variable type or name on the left side of the declaration. Assignment is right to left, or the value on the right is put in the variable on the left. This is mainly because programming languages tend to stand on the backs of previous languages, so once one language did it, most languages took up that trend. So why did the first language do it? Honestly, people writing assembly languages had to choose one, and people eventually settled on the right to left as the way to do it. If the variable's name is a piece of tape on the outside of the box, the variable's value is what's in the box, and its memory address is where the box is, then where does the variable's type fit into all of this? Rest assured that no matter the language, the type is indeed stored at one point or another, but the kind of language determines whether or not the type is stored within the box or elsewhere. Here's an example of some code. X equals 1, y equals 2, x equals y. On that last line, y doesn't suddenly have no value in it. Y's value is copied into x, so at that point, both x and y equals 2. Here's another example. A equals 1, B equals 2, C equals 0. Copy A's value into C, copy B's value into A, and copy C's value into B. This is code that swaps 2 numbers. Some words of caution. X equals 3 in the context of programming means something very different than what it means in the context of algebra. If you're familiar with algebra, you'll know x equals 3 means x equals 3. It most certainly does not mean that in coding. Equals always denotes assignment and always means puts the value on the right and the variable on the left. My examples will use variables with single letter names. Your variable names in practice should be meaningful so you remember what your code does. Primitive type versus reference type versus value type. A primitive type is a type that can't be broken into any simpler parts. Reference type is where the value in the box is the memory address of the value, and a value type is where the value is in the box. The interplay between value types and reference types is incredibly important. The difference between primitive types and value types? Primitive types are generally defined by the language they're in, and it's hard to make generalizations about them between all the languages. Value types are always just what their definition says, regardless of the language they're in. Some useful value types: ints, numbers without fractional parts, your normal counting numbers. It includes negatives. Some examples: -1, -2, -3, 0, 1, 2, 3. Floats, numbers with fractional parts, again it includes negatives. May be called doubles or wrapped up in one big number category along with the ints. Floats because the decimal point floats around. Chars, single characters of text. Example, the letter A. Some languages don't have this and just make you use strings for everything. Literals. When you place values directly in your code, they are called type literals, so int literal, char literal. Example, x equals 3. 3 is an integer literal, and that hashtag on that line, that's how you make a comment in Python. Another example, y equals hello. Hello is a string literal. Char z equals a. A is a character literal. Math. Most languages support your 4 basic operations right out of the box. Addition, x equals 2 plus 2, x now equals 4. Subtraction, x equals 4 minus 2, x now equals 2. Multiplication, x equals 4 times 2, x now equals 8. Division, x equals 8 divided by 4, x now equals 2. Most languages also support the remainder or modulo operator is the percent symbol. X equals 1 mod 3, x now equals 1, because when you divide 1 by 3, you have a remainder of 1. Watch where you swing that thing. Mixing types and mathematical operations can give you unexpected results. Some are simple and details you hardly ever have to worry about, while others can give you errors in your code. Plus sign. An int and an int equals an int. A float and a float equals a float. But if you mix an int and a float, you'll always get a float regardless of the order. The division sign. Int divided by an int gives you an int. The consequences of this means that 1 divided by 3 equals 0. To counteract this, make either one of the ints a float by making it int.0. Operation and assign operators are a way of modifying a variable by one of your 5 basic math operators, then right away storing that value back in the same variable. These operators accomplish nothing new, they're just shorter to write in code. Plus equals. Example, x plus equals 3. Add 3 to x and store it back in x. Minus equals, x minus equals 3. Subtract 3 from x and store it back in x. And so on for the rest of your operators. On the accomplishing nothing new point, x plus equals 3 could be alternatively accomplished by doing x equals x plus 3. The rest of the operation and assign operators could similarly be accomplished like this. For plus equals and minus equals, some languages support an even shorter shorthand, that being x plus plus, plus plus x, x minus minus, and minus minus x. Those in order mean use the value of x and add 1 to it, add 1 to x, then use its value, use the value of x and subtract 1 from it, subtract 1 from x and then use its value. Save for one other place in code, I tend to avoid using these altogether. Not completely understanding the concept or not thinking of how it will interact with other code can lead to dastardly hard to track down bugs. Please just use x plus equals 1 and x minus equals 1, except for the one other place I'll say plus plus or minus minus are good to use in. Strings. A string is an ordered collection of characters, chars. Depending on the language, strings may be mutable or immutable. This concept is tied to the value of reference type variables. In mutable, a value is able to be changed after it's created, and immutable, a value is unable to be changed after it's created. Strings and other immutable variables come with a certain caveat. When a string is immutable, you can't change it, but you can assign something different to the variable that holds the string. Example, x equals high. Now x equals high there. You've changed what the value of x is, but you haven't changed the string high itself. Escape characters. A sequence of characters that can be used to express something in a string that would either break the rules of the language if typed normally, or can't be typed with the keys on the keyboard, all prefixed with the backslash. I can never remember which one is called backslash and which one is called forward slash between those two. Think of horizontal left to right motion. The backslash seems to be going backwards. That's how you tie together backslash and backslash. Examples. Backslash n puts a new line in the string. Backslash t puts a horizontal tab in the string. And you can see how both of these work. In this example on the side, the backslash t tabs between the hello and the world, and the backslash n puts the rest of that string on a new line. Backslash puts a literal backslash in the string. Backslash quote puts a literal double quote in the string so the computer won't get confused and think you're closing the string early. Concatenation is joining 2 strings together. Most languages have it work like so. Example equals hi, y equals hi there. Z equals x plus y, so now z equals hi there. Using the plus sign, 2 strings are joined together. This again brings up an important point to remember, as depending on the context, the plus sign could be doing 3-ish different operations. 3-ish because you have float addition or integer addition. This is also why comments are important, and without the bigger picture it might be difficult to tell whether you're concatenating strings or adding numbers. Booleans, the last value type for now, named after George Boole, only 2 possible values, true or false. Check on the language you're using to see if you should capitalize these or not, it varies. In languages where you can convert these to ints, true converts to 1, and false converts to 0. When paired with logical operators, these are an important building block to be able to express yourself in code. Logical operators, the operators that can do operations on Booleans. 3 basic operators are and, or, and not. Some languages just let you write these words out lowercase to be the operator. Other languages require the following symbols. And is double ampersand, or is double vertical bar, and not is exclamation point. Why these symbols? And linguistically makes sense. The ampersand is used to mean and. I couldn't find a consensus on the origin of or's symbol, but it seems plausible that it originated because of its role in BNF. I have BNF's Wikipedia page linked in the description, but exactly what it is or why it's important isn't important in this video. Not makes sense as well because that symbol is half of how you express not equal to in many languages. Logical not. How to read this table. Given some Boolean variable p, if p is this one of true or false, this is what not p would be. So, true p, not p, false. If p is false, not p would be true. Logical or. Given some Boolean variables p and q, for some combination of p and q being true and false, this is what p or q would be. The only way p or q is false is if they're both false. How to read this table for the logical and. Given some Boolean variables p and q, for some combination of p and q being true or false, this is what p and q would be. P and q is only true if they're both true. Comparison operators. Operators that take in 2 values, often ints and floats, and return a Boolean answer. All these operators are ones you're most likely familiar with from math. Greater than, less than, greater than or equal to, less than or equal to, not equal to, triple equals to. This is only applicable in languages like PHP and JavaScript where double equals brings great pain. All these operators take a value on the left, a value on the right, and return true if the statement is true and false otherwise. An example, x equals 5 greater than 3. 5 is greater than 3, so now x equals true. The horror of double equals. This is a Python example. Seems normal, right? High should equal high, right? What on earth? You have 2 strings, you compare high, it's true. You have 2 strings, you compare high, it's false. This isn't wizardry, but exactly why this is out of scope for now. The big picture for now is, double equals works the way you think it would for value types, but can have weird quirks come up for reference types. Stay tuned for the next video where I'll cover conditionals. Ciao.